Now let me show you how we can actually do experimental measurements to see what direction the force is. Now I'm going to do it like this. I'm not going to say which way our magnet is oriented, as in this case, I have a magnetic source, and I want to do a few experiments to determine the magnitude and direction of the magnetic field. Our experimental probe is a charge moving with the velocity v. And let's suppose in my first experiment that I measure a force in a certain direction. And let's just imagine, for simplicity, for drawing on this screen, that our magnetic force, F1, is pointing like that. So this is our first experiment. That's why I call it F1. Well, because of the nature of the cross product, if I take a plane that's perpendicular to F1 and V, I know, because a cross product, this force is perpendicular to both V and B, that B must lie somewhere in this plane. So our first conclusion is B lies somewhere in this plane. And maybe we say, just schematically, you can see that B will lie like that. And we'll take a Q positive. So all we know from this first measurement is we measure force, we've looked at the velocity of the particle, we know which way B points. It has to be perpendicular to the plane of F1 and V. Now our second experiment is to pick out plus or minus the direction of B. So imagine that you can, now that we've picked out this plane in space, you can send this charge anywhere you want in that plane. And suppose in particular that you send the charge, let's draw the plane, and I'll do a few examples. Right now, we get V1, and we had F1. And now I send that charge in this direction, V2, and maybe the force diminishes a little bit, F2. And then I send the charge V3 in a certain particular direction, and I get that the F3 is 0. Based on these measurements, I know that the magnetic field, because again it's a cross product, if B is in the direction of V, then there's 0 cross product, and the force went to 0. But keep in mind that if vectors are antiparallel, the cross product could also be 0. And so what I can only conclude here is that B is in either one of these directions. It could be here, it could be there. Now, if our charge was positive, there's one extra piece of information that we know. So as I sweep out these possible trajectories, notice that the force is in this direction. And that tells me, by the nature of the right-hand rule in the cross product, that this is the one, that's the B that is picked out. Because if B were pointing in the other direction, the cross product would be down. So I measure the force, I measure the direction of the force, I send charged particles out until the force, if I've got a force going up and the force is diminishing, and I find that direction in which there is no force, then I know the direction of B. So that's pretty tricky. And it turns out, you'll see in one of our practice problems, that you actually only need to make 2 measurements in the plane. And then you can figure out the direction of B. That's a pretty tricky problem. So that gives us the direction of B, and now we'll next talk about the magnitude of B. Now I want to describe how we define the magnitude of B. So again, we have our magnetic source here, and we had a test charge, and that was moving. And let's look at it this way. We had our test charge moving, and we measured a force in this direction, and that told us the plane of the B field is like this. So that was what we did before. It told us that B lies somewhere in that plane. Now what I want to do is find the following thing. I want to find the direction in the plane. So again, experimentally, I send my test charge in a variety of different directions, and suppose that the test charge is going in the plane like this, and that after making a bunch of measurements, I find out this is the maximum force that the test charge had. Again, our test charge is positive. Therefore, I know that the magnetic field is perpendicular to the velocity because a cross product has its maximum value when the two vectors are perpendicular. So that tells me how I could get the magnitude of B as follows. So the cross product, the magnitude of the cross product now, is just equal to the magnitude of Q. We've been assuming that's positive. The magnitude of V, this is the, let's call this one, remember, this is the maximum value, Q times the magnitude of B. And so we see that we can find the magnitude by experimentally measuring the maximum force on that moving charge. Now, in SI units, we use a Tesla to measure magnetic field, the units for the magnetic field. And from our definition here, we can see that 1 Tesla is equal to a Newton, Coulomb, meter per second. And from these two videos, you can see that magnetic phenomena is a little bit more complicated, and it really is all arising from the experimental cross product that appears in the experimental Lorentz force law.